This is going to be section 5.5, Systems of Inequalities. Okay. Now, this is the last section of chapter 5. On this one, for inequalities, we're going to solve them in a way similarly to what we did before. Remember to find out the values of x that made an equation greater than 0 or less than 0. We had to find test points that will make that inequality true. And the process is going to be very similar, but in this case we're going to be solving systems of inequalities in two variables, x and y. So the only method of solving is by graphing when it is two inequalities. When it is two variables. Let's start with something simple. As a reminder, this is a topic from Algebra 1 that you should have, you might have covered before, that you should remember. Like, let's say, graph the following inequality. So, first thing that we need to do, just like we did on the regular inequalities, is that we need to make this an equal sign, and then we need to find the solutions for this equation first. Now, since this one is two variables, again, to find the solutions to that equation is we're going to find the graph of that equation, basically. Now, to get the graph of that equation, we're going to first set it in y equals form, and that is going to be negative y equals negative 6x plus 12. Then we have to divide the negative 1 on both sides to get rid of the negative, and that gives us y equals positive 6x minus 12. Now what's going to happen is this. Let's go ahead and graph this equation. So it tells me right here that when x is equal to negative 12, right here, well, this is my y-intercept, which means that it's going to cross the y-axis at negative 12. Remember, this is a line, because any equation that has x and y, it is just a line. So, and you see that the 6 right here represents the slope. What does it mean by a slope of 6? That's 6 over 1, with meaning that the graph is going to increase 6 units up, and it's going to go 1 unit to the right. So from the negative 12, then we're going to move it 1, 2, 3, 4, 5, 6 units up, and to the right 1 unit. Here's the next point. Then 1, 2, 3, 4, 5, 6 units up, and to the right 1 unit. Here's another point. 1, 2, 3, 4, 5, 6 units up, and to the right 1 unit. Here is another point, and so on. Okay. Now, let's before you graph this, let's remember one more thing about inequalities. We know already that this equation is going to be represented with a line. Okay. Don't graph it yet. Just wait a couple of seconds here. This is a line. So when I graph this line, then this line represents the solutions to the equation 6x minus y equals to 12. Those are the solutions to that equation. But now, is that what we're actually looking for on this problem? The answer is no. What we are looking for, we're looking for the solutions for this inequality. We want to find out the values of x and y that make this greater than 12. So you see that with the line being graphed here, the graph was divided into two sections. But first of all, I want to cover something about the line. What happens, let's say, if I substitute any point from this line back into the original right here? What is going to happen? Let's say, pick one point. If we substitute this one, that point, you see, it's 3, 6, right? So it's a 3, 6. So if I substitute the x with the 3 and with the y with the 6 into the original, which is 6x minus y is greater than 12, look what we're going to get. 6 times 3 minus y, which is 6, must be greater than 12. That gives us 18 minus 6, which is going to be 12. What do we know about this? 12 greater than 12. That it is a false statement. So what does it mean by false statement? That means that this point 3, 6 is not a solution. And likewise is going to be, if I replace this one, it's also going to be not a solution. It's going to give me a false statement. If I replace that one, it's going to be not a solution. If I replace that one, it's going to be not a solution. So to say that these points are not solutions of the equation, just keep the following in mind. We don't have to do the test point for the line to test if the points on the line are solutions or not. If the inequality does not have an equal sign on the bottom, anytime this happens, the line is not going to, the graph is not going to include these numbers on the line, on the graph, because they're going to make the equation false, or the original inequality false. So that means that for these two cases, we're going to use a dashed line. Dashed line, it's another way of saying, which is this is a dashed line. It means that the points on the graph of this equation, the one that equals to 12, are not included in as a solution, because they're going to make this inequality false. So dashed line means the following, so we're just going to graph it like this. This is what a dashed line means. Okay. Now you can graph it. That's exactly the way the graph should look like. And remember that by dashed, we're saying that these points right here are not included because they make the original inequality false. So they are not real solutions of that. Okay. Next, the next thing is this. Now we need to find the actual solutions for this inequality. I'm going to erase this because we don't actually need it. Okay. Now we're going to find the actual solutions of this inequality. We want to find all of the points that make this inequality greater than 12. To find that out, we're going to use test points. And if you look at the graph, because of the line that we drew right here, the graph was divided into two parts. We have this section right here on the left side, and we also have this section right here on the right side. Those are the two sides of the graph now. Okay, so what we need to do is we need to use a test point on each side, whichever one you want, and you're going to substitute it into the original inequality and determine if it's true or false, just like we did on another section on inequalities. So on the left side, I'm going to use my test point, and I always recommend use the test point 0, 0 if you can use it. Okay, so I'm going to substitute 0, 0 as my test point. Oops. So that means that x is 0 and y is 0, right? So we're going to replace the x with the 0 and the y with the 0 in this original inequality. So if I do that, then you get 6 times 0 minus 0 is greater than 12. So you get right here, 0 is greater than 12. Is that true or false? That is going to be a false statement. What does that mean? That any point located on the left side right here is going to give us a false statement as well. So all of the points on the left side are not solutions. So none of the points on this area are solutions. Okay. So now we're going to test a test point, any test point that you wish, on the right side. Okay. So let's say I'm going to use this one, 4, 1. And you will see that if I put the 4, 1, look what's going to happen. When x is 4 and y is 1, 6x minus y is greater than 12. So 6 times 4 minus 1 is greater than 12, which is 24 minus 1, and that is 23. 23 greater than 12 is true. Since this is true, that means that any point that I substitute into the original inequality that lies on the right side of this line, it is going to be true. Any point on this side will be true, meaning that any point is a solution on the right side. So to say that any point, like to say that this point is a solution, or that point is a solution, or this point is a solution, or that point is a solution, to say that all of the points on this side are solutions, we're just going to shade in the right side of this line, and that basically saying that any point on the right side is a true solution. Next equation. We're going to graph this in a system. Let's start with this one. Graph the following inequality. X minus 6 squared plus y plus 7 squared is greater than 36. So on this system, you have a special type of graph that we need to cover. This is going to be the graph of a circle. Anytime you have an equation in the form x minus h squared plus y minus k squared equals a number squared, that represents the equation of a circle. Now, on the equation of a circle, there are two things that we need to know. The center of the circle. The center of the circle is going to be the opposite of these two numbers inside of the parentheses. The opposite, okay, which is hk. And the r that you have on the right side represents the radius of the circle. So the radius is going to be my r. Okay, so what does that mean? Center of the circle. I don't know what's going on. Center of the circle means this, right? So that is my h comma k, and the radius of the circle is the distance from the center to any side on the circle. That's what the radius means. So that's exactly what we are going to do next. Okay, so to graph this circle, first of all, let's determine what the center and the radius is. So on this circle, the center is going to be the opposite of those two values, which is going to be positive 6 and negative 7, the opposite of these two. And the radius, now you see that according to the equation, this number is the radius square. So if I want to get the radius, all I need to do is get the square root of that number. So the square root of 36 is going to be 6. So I'm going to be extending this graph a little bit more because we're going to need a couple of more lines. Like about 3 lines down and 3 lines to the right. Okay, so the circle has a center of 6 comma negative 7 right here, and it has a radius of 6. Radius of 6 means that from the center you're gonna go 6 units to each side. From here you're gonna go 6 units to the left. 1, 2, 3, 4, 5, 6. Here's 1 point on the circle. From the center you're gonna go 6 units up, so it's 1, 2, 3, 4, 5, 6. From the center you're gonna go 6 units to the right, 1, 2, 3, 4, 5, 6. And from the center you're gonna go 6 units down, 1, 2, 3, 4, 5, and 6. And then you're gonna connect these 4 dots on the outside with a circle. Okay. Now you see that this one does not have an equal sign, so once again this one is a dashed graph. Dash means that the values on the graph will not be included because they will make the original inequality false. So we're going to make this a dashed circle. So this is what that one is going to look like. Now we need to use test points to determine what the solution is going to be. Now there are 2 possibilities, there are 2 regions right here that could be my solutions. It could be that all of the points on the outside of the circle are true solutions, or it could be that the points inside of the circle are the true solutions. So those are the 2 different areas that you have there. So I'm going to start testing the point 0, 0 as usual. And 0, 0, you see that lies on the outside. So that 0, 0 is going to test if the points on the outside of the circle are the true solutions or not. So I'm going to replace the x with the 0 and the y with the 0 into the original right here. So if I replace x with 0 right here and the y with the 0 right here, what are we going to get? Negative 6 squared plus 7 squared, which is 36 plus 49, and that is going to be 85. Greater than 36, and that is true. So what does that mean? Since 0, 0 makes that true, that means that any point on the outside of that graph is going to be true on the original inequality. So we're going to shade in everything on the outside of this circle to say that any point on the outside is a solution. And this is another thing that I want you to keep in mind. When you're solving inequalities, only one region can be the solution for the inequality. There cannot be two regions. Once you find the one that makes it true, that should be the only possible region that will make it true. Okay? Next problem. Now we're going to solve a system of linear equations. System of equations. Let's start with this problem. System of inequalities. This is a system of inequalities. We're going to solve the inequality 2x minus 6y is less than or equal to 12 and 3x minus 2y is greater than 6. Okay, so first of all, these two equations, you notice that both of them are lines. So what we need to do for the lines, first thing is that we need to change that to an equal sign, and we need to put them in y equals mx plus b form. So that means that I need to solve for y. So move the 2x over right here. So that gives me negative 6y equals negative 2x plus 12. And then we're going to divide the negative 6 on both sides of the equation. And that is going to give us y is equal to negative 2 divided by negative 6 is going to be positive 1/3 x, and 12 divided by negative 6 is minus 2. So this equation has a y-intercept of negative 2, and the slope of this equation, it is going to be 1/3, meaning that it is going to go up 1 unit and to the right 3 units. Let's go ahead and graph that here. So we're going to start with the y-intercept of negative 2, and then the graph is going to go up 1 unit, to the right 3 units, up 1, and then to the right 3, up 1, and then to the right 3, and so on, and so on, and so on. Now you see that this one has a less than or equal. It has the equal sign. So this one is not going to be dashed. So this is the first time we're going to graph it. We're going to graph it with a regular solid line. The solid line, it's another way of saying that the points on the line will be true solutions as well. So they are included. That's what the solid line basically is going to tell us. That the points on the line will be true solutions, and therefore they will be included. Next one. Now we are going to graph the second inequality. Well, second equation. First of all, we're going to graph the equation. So we're going to set that equals, first of all, to 6. Let's put it in y equals mx plus b form. I'm going to take away the 3x from both sides. So it gives us negative 2y equals negative 3x plus 6. Then we divide both sides by negative 2. And then again, negative divided by negative is positive, so it's positive 3/2 x. And 6 divided by negative 2 is negative 3. So right here, we get that the y-intercept of this line is negative 3, so that means it starts right here on the bottom. and then the slope right here, it is a 3/2. What does it mean by a slope of 3/2? It means that it goes up 3 and to the right 2. So we're going to go 1, 2, 3 up and 2 to the right, and this is the next point. 1, 2, 3 up and 2 to the right, this is the next point. 1, 2, 3 up, 2 to the right, this is the next point. 1, 2, 3 up, 2 to the right, 1, 2, 3 and 2 to the right, this is the next point, and so on and so on and so on. Okay, so, and look at this one. This one does not have an equal sign, so that one automatically is going to be a dashed graph. Dash meaning that the points on this line will not be included because they're going to be false solutions. Now, keep in mind that when we solve a system of inequalities, a system means more than one simultaneously. There might be, the number of regions is going to go from 3 all the way to 6 regions, usually. So in this problem, you see that we have this region on the top right here. We have this region on the bottom right here. We have this region on the bottom right here, on the bottom of these two. And we have this region on the little piece right here. We have to find out which one of those 4 is actually going to make, now in this case, since it is a system, it must make both of them true. So we're going to start by picking a test point. Okay, we're going to start discarding the possibilities one by one until we find the one that makes both of them true. So then, the test point right here, I'm going to start testing the 0, 0 as usual. So I'm going to test to see, you see where 0, 0 is located. 0, 0 is on this part on the top. So that 0, 0 is going to test to see whether all the points on this little area right here are true or false. So let's go ahead and test the 0, 0, but it has to be tested on both, remember. So I'm going to do one by one here. So test point, I'm going to do the 0, 0. So I'm going to first of all test it onto the first one. X is equal to 0 and y is equal to 0 on the first inequality. The first one is 2x minus 6y is less than or equal to 12. So if I put a 0 for the x here, and if I put a 0 for the y here, right here we're going to get 0 is less than or equal to 12. Is that true? Yes, that is true. Now let's test it onto the second one. 3x minus 2y is greater than 6. So if I put a 0 for the x right here and a 0 for the y, then you get 0 minus 0, which is 0. Is that greater than 6? No. So this is false. In order for this to be a solution of the system, it must be true on both. So that means that all of the points right here are not going to be solutions. So we have to test another region somewhere else. So I'm going to test now this one right here, this piece right here on the right side. Let's pick any point on that region, whichever one. So I'm just going to say, let's say this one, 5, 2. So if I substitute the test point 5, 2, let's see if that's going to be true. X is equal to 5 and y is equal to 2. So I'm going to go first to the first inequality. 2x minus 6y is less than or equal to 12. And I'm going to replace the x with the 5 here and the y with the 2 here. That gives me a 10 minus 12, which is negative 2. Is negative 2 less than or equal to 12 true or false? That is going to be true. So then we're going to check the second one. 3x minus 2y is greater than 6. If I substitute the x with the 5 and the y with the 2 right here, that gives me a 15 minus 4, which is an 11. Is that greater than 6 true or false? That is true. That means that all of the points on that little piece on the top right hand side of this graph is going to be true. So we're going to shade in everything in the middle of these two lines on the top right here to say that any point in this little piece is a solution to both inequalities. And remember what I mentioned on the previous problem, there's only one possible solution. One region can be the solution, not more than one. Once you find the one that makes both of them true, then that's it. You don't have to look for the other two regions right here. I don't have to test this one, I don't have to test this one, because automatically they're going to be false. Now, the next problem we're going to do is going to be this one. Graph the solution set of the system of linear inequalities. Now, first of all, I'm going to change it to an equal sign as usual. X equals to 7 and y equals to -2. Now, these two are two special types of equations. X equals to 7, if you remember, it is a vertical line, and y equals to -2, it is a horizontal line. So x equals to 7 is going to be a vertical line passing through the x equals 7 value. And one thing is that both of them, as you can see on the inequalities, both of them will be solid, because you see that it has a less than or equal and greater than or equal. So both of them will be solid. So let's go ahead and graph a vertical solid line at x equals to 7. Right here. Oh, that's x equals 6. Vertical solid line at x equals 7. Second one, we said that it is a horizontal line at y equals -2. So we're going to graph a horizontal line on the -2. And also it's solid. Once again, the graph was divided into 4 regions. So we have to test each one of those 4 regions until we find out the values that make both of them true. So which value would be the best one to start with? 0, 0, right? So 0, 0 is going to test to see whether all the points on this top left hand side are going to be true or false. Remember, the 4 regions will be this one at the top, this is one region. This one at the bottom right here, that's another region. This little one on the right side on the bottom, and this one on the right side at the top. Those are the 4 regions that we need to test until we find the true. Okay? Now, let's begin with the 0, 0 to test the top left hand side region. So we're going to replace x with 0 and y with 0, and it has to be tested on both. The first one is x is less than or equal to 7, the second one is y is greater than or equal to -2. So if I put a 0 right here, is 0 less than or equal to 7 true or false? That is going to be true. Now if I put a 0 here, 0 greater than or equal to -2, and that is also true in this case. Now we don't have to search anything else, because once we find a true, that's going to be it. That means that any point on the top left hand side right here is going to be a solution to both inequalities. And remember that there can only be one possible region as a solution. What if this one wasn't the solution? Then we need to go back and check the bottom one, the right one, and the right one on the bottom, either one of those 3 regions, to determine which one makes both of them true. Next one. We're going to graph these two next. Graph the solution set of the following system of inequalities. X squared plus y squared is less than or equal to 49, and x plus y is greater than 5. First one. I'm going to change it to an equal sign, as usual. What kind of equation is this? X squared plus y squared, remember, it is a circle. And on this circle, you see that there is no h value and there is no k value. So that doesn't mean that there is no center. That basically means the following, that the center is going to be the point 0, 0. And remember that to find the radius, I need to get the square root of the number on the right side. So the square root of 49 gives me a 7. So this is going to be a circle that starts on 0, 0 from the center. And then the radius is going to be 7, which means it's going to go 7 units to the left, right here, this is 1 point. From here, 7 units up. From here, 7 units to the right. And from here, 7 units down. This is going to be our circle. And you see that it has an equal sign on the bottom. That means it is a solid circle. Okay, so we're going to graph a solid circle right there. Okay, next one. Now we are going to graph the second equation. The second equation, it is a linear equation. X plus y equals to 5. So for that, what do we need? We need to put it in y equals mx plus b. So subtract the x, and that gives us y equals negative x plus 5. So then what do? We say that on this line, the y-intercept is 5, and the slope, it is negative 1 over 1. So it is going to intersect the y-axis at 5 right here, but then the slope negative 1 over 1 means that from that y-intercept is going to go down 1 and to the right 1, down 1 and to the right 1. So down 1 to the right 1, here's another point. Down 1 to the right 1, here's another point. Down 1 to the right 1, here's another point, and so on and so on and so on and so on. And one more thing, this one does not have the equal sign, so this one is a dashed graph. So we're going to make it a dashed line in this case. So once again, we ended up with a graph that was divided into 4 regions. And the 4 regions are, as you can see, this one inside but on the bottom of the line, this one inside but on the top of the line, this one on the outside on the bottom of the line and on the circle, and this one on the outside on top of the line and on top of the circle. Those are the 4 different regions that we must test, one by one, until we find the one that makes both of them true and true. Okay, so I'm going to start by testing the middle, which is 0, 0. And 0, 0 is going to test this bottom region right here, this inside. So let's test it out. So if I replace the x with the 0 and the y with the 0 onto the first one, let's see the first one first and see what we get. 0 squared plus 0 squared is less than or equal to 49. 0 plus 0 is going to be 0. Is 0 less than or equal to 49? That is true. Let's check the other one. X plus y is greater than 5. 0 plus 0, that's going to give us a 0. Is that greater than 5? That is false. So what does that mean? That in the anything in the bottom right here, it is not going to be a solution. It is going to be false. So we're going to test a different region. Alright, so first of all, I'm going to test the ones inside, and then if those don't work, I'm going to try the ones on the outside. Now I'm going to try this one on the top, okay, to see if that one is a solution. You need to pick a point. So let's say, let's put this for 4, 4. That would be a good point. 4, 4. Anything that lies on this little piece. Okay? So I'm going to test the 4, 4 in both of them. So x is 4 and y is 4. So I'm going to put both equations. If I substitute a 4 here, and if I substitute a 4 here, that gives me a 16 plus 16, which is going to be a 32. Is that less than 49 true or false? That is going to be true. And then I'm going to substitute the 4 and the 4 here. 4 plus 4 is going to be 8. Is that greater than 5? That is also true. So we don't have to check for the other 2 regions, because we already found the one that makes both of them true. So that means that any point on this little region at the top is going to be a solution, because it makes both of the inequalities true. So any point on this little region is a solution to both inequalities. Next and last question is going to be this one. Graph the solution set of the following system of inequalities. So first equation that we have here is x squared plus y squared equals to 25. This one is again a circle. X squared plus y squared is a circle. So we need two things. We need the center of the circle, which again, since there is no h and k, once again is 0, 0. And the radius, we can find it by getting the square root of the number on the right, which is the square root of 25 is 5. So this circle starts from the center, and then it's going to go 5 units to each side. 5 units to the left, 5 units up. From here, 5 units to the right, and from here, 5 units down. And you see again that this is a solid circle. So we're going to create a solid circle right here. Oops. The next one. Now the next graph, it is a little bit different. You see that this one, it is a parabola. How do we know? Because only the x is being squared. Now it is going to be also a, well, this one is a dash, not solid, because it doesn't have the equal sign. So for this parabola, first thing we need to do is put it in y equals form. So I'm going to move the x squared over to the other side by adding the x squared, and that gives us y equals to x squared minus 1. And then we need to graph it, and I believe the simplest way for us to graph this parabola is by using the table as we used to do before. I'm just going to do my -2, -1, 0, 1, and 2 as usual, and I'm going to substitute them into the equation. The equation is x squared minus 1, y equals x squared minus 1. So -2 squared minus 1, this one x is -1 squared minus 1, x is 0 squared minus 1, x is 1 squared minus 1, and x is 2 squared minus 1. What are we going to get? -2 squared is 4, minus 1 is going to give us a 3. -1 squared is 1, minus 1 gives us a 0. 0 squared is 0, minus 1 is -1. 1 squared is 1 minus 1, which is also a 0. 2 squared is 4 minus 1, which is going to be a 3. So the points for this dash parabola are going to be -2, 3, -1, 0, 0, -1, 1, 0, and 2, 3. And like we said, this one is going to be a dashed parabola. Last but not least, we're going to use the test points to determine what the solution of this parabola is going to be. I'm going to start by testing the 0, 0 as usual, right here. And what is 0, 0 going to test? It's going to test to see if all of the points in this little piece are true or false. Remember that we have several regions. We have this one inside, we have this one on the bottom inside of the circle, but on the bottom of the parabola. We have this region on the outside of the parabola and on the outside of the circle, and we have this region right here inside of the parabola but outside of the circle. So those are the 4 different regions. So first of all, we're going to test that yellow region by using the 0, 0 as usual. Okay, so I'm going to put test point. It's going to be 0, 0. So x is 0 and y is 0. So we're going to go to both inequalities here, and we're going to substitute the x with the 0 and the y with the 0. That was my test point. So if I put 0 squared plus 0 squared, that is going to be 0. Is that less than 25 true or false? That is true. 0 minus 0 squared, that is also going to be 0. is that greater than -1, true or false? That is also true. Since that 0, 0 makes both of them true, then end of the search. That means also that any point where the 0, 0 is, which is this little piece inside of the circle and inside of the parabola, is going to be true on both inequalities. So we shade in all of the inside of this little piece right here, where the 0, 0 is located. And this, students, basically concludes section 5.5.